today I wanted to go over how to create the MakeCNC.com cat head business card holder. We've done a tutorial on how to do this within Vectric software, such as Cut2D or VCarve Pro. But we haven't really delved into how to do so in Fusion 360, and that's what I wanted to cover today. So here we have the PDF that is from MakeCNC.com, and we've actually partnered with them to create 5 different projects. They're all great beginner projects for your CNC machine, and they are available for free to STEPCRAFT customers. So let's dive right in. This is the PDF that comes with the project itself, and you can download it in a .dxf format, which is what we'll be using. So you can see here we have the parts list, the instructions, and what the final project will look like. Now before we dive right into our CAM, I just wanted to quickly cover the inside corners. These are 90-degree angles. Now that's an issue because if you've used a CNC machine before, you realize that all the tooling is round. And the solution to that is what we like to call Dogbone fillets. Dogbone fillets, because of how they're recessed into the piece, allow for a perfect edge-to-edge fit, whereas a normal fillet would leave a curved radius. So let's begin our file creation in Fusion 360. Now we want to begin by actually making the dimensions of the stock we're going to be using. And we can do that by creating a sketch, selecting our plane. We've moved to our top face. And I like to use a little shortcut. You can hit S and you have all your shortcuts here. I like to use a 2-point rectangle. This allows me to start with the bottom left corner at the very center of our coordinates. So we can move out. We want it to be 12 inches in length by 6 inches in height. Now I actually made this 8 inches. I wanted to give myself an inch on each side for the clamp hold downs that come with our D-series machines. They're a great work holding solution. They allow you to do a lot of stuff right out of the box, and I wanted to incorporate them into this project. So I gave an extra inch on each side so that there'd be enough room for the tool to cut its project out. So once we have our dimensions, here's our stock. Now there's something very important to remember when you are creating a project like this, where this piece is vertical and it slips into this little notch which is horizontal, something like this. The thickness of your stock is going to dictate how well this piece and this piece fit together. So it's very important to measure your stock. Now, if we take a pair of calipers to our stock, the example piece that I'm using is, instead of an 1/8 inch 0.125, it is 0.124 inches thick, meaning I'm going to have to scale my project to the correct dimensions so that everything interlocks. To do so, I'm going to start by fully modeling my stock, and I can do that by hitting E or selecting Extrude up here, and I'm simply going to extrude it down the thickness of my stock, so 0.124. And I extrude it down so that it's easy to place my DXF file right on top. Hit enter, and as you can see, we've now created our stock. So this is essentially the material that you'd put in the machine. Once we have our stock, we can move to our top view and select Insert, and we want to insert our DXF. Now, this DXF file that we're using for Fusion is a little bit different than the normal DXF that you would use with Vectric. As you can see, it says with dog bones, and I'll cover that in 1 second. So if we open that sketch, just importing, and there we go. So now we have our sketch right here, and we can actually move it around. I'm just going to move it about an inch off the bottom, so it's sort of centered between those two pieces where I want to have that work holding. We can move it over a little bit more. That way we can almost get two projects out of this one piece of stock, which is really handy. This has been moved around so that the space is saved. You can see here in our preview, this is how the DXF imports by default when you download it from makecnc.com. And this is just fine if you have expendable stock, but by rearranging these, as long as there is a 1/8 inch distance between each piece, you can save a lot of room, as we see here. So now that this DXF is inserted, we can hit OK, and our DXF is inserted right on top of our stock there. So we have enough room there for our clamps. Now, I wanted to quickly touch on what Dogbone fillets are. In Fusion, you are unable to create Dogbone fillets without an extension or without hand drawing them yourself, both of which defeat the purpose of an easy first project tutorial. So what I did was I took my DXF file from Vectric with the Dogbone fillets already made and imported it back into Fusion. We offer this modified DXF file for those of you who are using Fusion 360 to create their project. Now, before we continue, I just wanted to explain something briefly. If you look here, I've created this line here, as it's important to understand why we would scale a project. So if I hit I, which is inspect, and I select this line, and then I select this one, these two lines, 92 plus 33 is 125. So we can see that this length is 1/8 of an inch. It's exactly where that 90-degree angle would be without the Dogbone fillet. So what we can do, stop this sketch, and we move out, and then we can actually scale it. So we offer a scaling tool on our site, and that is right here. So you see this is the scale that the design was made to. This is the actual thickness of our stock, and this is the scale percent. Now, when you're scaling in Fusion, this value would actually be 0.9920. That's how that would look. So we can go ahead and scale our drawing. So select scale, and then the entities that we want to select, and we change that to 0.992. Now, if we go back to this little example that I showed and hit I and inspect these two pieces, you can see there is a 1 thou difference now, which means it would be 0.124. So now the project is scaled correctly. In our case, our stock is pretty close. So I'm just going to clean these up really quick. There we go. So now that our project has been scaled, we are ready to run our toolpath. So to do so, we can move over to our CAM environment. Now we're in our CAM environment, and I actually want to change my unit type to inches. There we are. And we can do our setup. So here's our setup. We have our X, our Y, and our Z. Now I like to start at the front and make sure that it's starting at the model. We have some stock, which I want to change. I do not want any additional stock. So I want our start point to be right at the top of the work. Now our setup, I want to do something a little bit different this time. I actually want our stock point to be the top. There we go. So our starting position is actually at the very corner of our workpiece, right where the drawing begins. And you know what I'm actually going to do? I'm going to move that up here. And I did that just by selecting origin, selected point, and then selecting this line. And I did that because I gave that extra inch on each side for the clamping bars. And if my spindle were to start here, it would actually run into my work holding. So being conscious of your work holding when creating cam is very important. So now our setup is complete. We can see our height in Z. That's the correct width. And we can hit OK. And our setup is done. So once we have our setup, we can move into doing our toolpath. So we're going to do a simple 2D contour. Select that. And now we can set up our tooling. So we select our tool. And this is one that I've created specifically for this project based on the actual tool I'll be running. Now, to create your own, simply select this icon and select the type of end mill you have and the number of flutes, and then fill out this information as applicable. Sometimes you'll have a different tool for different projects. Of course, you can build a tool library based on the tools you own personally, but these vary. The only thing that's going to be the same for everyone watching this video is the diameter, which is an 1/8 of an inch. So I have this 1/8 inch end mill that I've created here, and I can select OK. You'll see it's loaded up in there. Now, the main things that we're going to worry about is our feed rate and our spindle speed. Now, spindle speed you don't have to worry about if you have an MM1000 or a Crest spindle, something that isn't electronically controlled. If you have an HF500 and you're interfacing it with CNC to control the RPMs through the software, that's something that you'd set here, and you could set that at 12,000. Personally, I will be using an MM1000, so this is not important to me. For those of you who are using an MM, I found the optimal setting is around 4 on the dial. Now, our cutting feed rate is going to be 26.322, and that is in inches per minute. That is about 10 millimeters per second. Now, feed per tooth is fine as it is. Our lead in and lead out feed rates, we want to keep the same. So we can actually take this value, copy, and just paste that in. And we actually want our ramp and our plunge to be the same. Our ramp we can actually turn down to 15, since it is a little bit slower coming into contact with the work, but from there we can speed it right back up. So everything here can stay the same. We really want to just worry about our cutting feed rate, anything to do with our feed rates, and our spindle speed. Now we can move on to our geometry. So we simply select the contours that we want the bit to cut out, and then these little arrows, we actually want them on the outside of the line, as that means the bit is cutting up against the outside line as opposed to on it or inside. You'd use inside for a pocket operation. There we go. Now we want to set up some tabs. Now I know this looks strange when it looks like it's inside. It's not, and you can tell that by the location of the tabs. If these were on the inside, it would be cutting the inside line. That's a nice way to check if your arrows are correct, because sometimes in situations like this, it's kind of hard to tell where it's actually cutting. It's indicating that the tool is going to travel this way and into the piece and then back out. But that's hard to tell from that view. So now that our tabs are set up, we can go to our heights. Now we are in the top view, but we can actually move to the front, so it's pretty easy to visualize. My top height, I want to start at the model top, and the bottom height, I want to be the model bottom. I want to give the bottom height a negative 10 thou offset, which allows the spindle to pass all the way through the piece. When doing this, just make sure you have a sacrificial board underneath, because you don't want to damage the bed of your machine as the tool is passing all the way through. Everything else should be fine. Now we can go to passes. Our sideways compensation should be on conventional. Everything is fine. We don't need to do any finishing passes or anything fancy like that. We simply want to do multiple depths, and our step down should be half the diameter of our bit, so that's 0.0625. We don't need a finishing step down. Everything else is just fine the way it is. We can go to linking. We want to preserve rapid movement, allow rapid retract. We can keep the tool down as much as possible. And for our lead-ins and transitions, we can keep it as is. We can add a ramp, and this is useful because instead of just plunging directly in, it will do a sort of ramp in, and that puts less stress on the tool and on the machine. So once we've done all that, we can hit OK, and it's going to render our toolpath. So now that this is all rendered, we can actually simulate and see how that works. Now when I do a simulation, I like to make my tool transparent and just show the shaft of the tool. I like to turn my toolpath off, and I actually like to turn my stock on and to plastic vinyl. It helps kind of visualize the cutting operation here. And lastly, I like to turn my cam component off, as you get to see the actual workpiece as opposed to your model showing through as you cut. Run that simulation. We can speed it up if we want to, make it a little easier to see. You can see it's cutting those tabs. On that last pass, it's keeping that material there. And it's all done. Now that we're all done with our toolpath and we've simulated it and everything is to our liking, we can do our post-process. I'll quickly go over how to generate a file to run on our machine from another recent Fusion tutorial I've done. This short clip will walk you through exactly how to download, install, and save your file to run it on your machine. Simply go to the link above and enter into the search bar STEPCRAFT. Once you find STEPCRAFT CNC, select Download and Save File. This will save as a .cps file. Now to make this process a little bit simpler, we can go back to Fusion 360, and in our post-process, we can select Setup and use a personal post-process. This will allow us to copy this file location and paste it into the download, allowing that .cps file to go directly into our personal post-processor folder. Now, it will not appear by default. You'll actually want to cancel your post-process and reselect it. Then go to Setup and Personal Post Library, and we should have our STEPCRAFT post processor appear by default. Once that's all set, we can select Post, and it will prompt us for a file location. I'll call my file STEPCRAFT test file and save it to my desktop. This file will save as a .nc file. Simply load the .nc file into UC CNC and you're ready to run your project.